Good day everyone, I am Ranalyn Sinacario. I am going to report about the processes and measurements of infiltration, while my partner will report about the processes and measurements of percolation. So first, we will determine its objectives. Define what is infiltration and percolation, the process of infiltration and percolation, identify what methods used for measurement, and differentiate infiltration and percolation. So next, what is infiltration? So it is the process of water entry into a soil from rainfall or irrigation. As infiltration divides water resources into surface and subsurface water, it is a key process in the hydrological cycle. So the rate of infiltration is primarily controlled by the rate of soil water movement below the surface, and the soil water movement continues after an infiltration event as the infiltrated water is redistributed. So, infiltration depends on the availability of water at the soil surface and on soil characteristics, which influence the water retention capacity and the hydraulic conductivity. So the movement of water into the soil is caused by gravitation and is affected by forces of soil particles on the water. Next, so this is what hydrological cycle looks like, but we will focus on infiltration. So this is infiltration. So what I have said earlier, infiltration is the process of water enters into a soil. So next is the infiltration rate, the velocity or speed at which water enters into the soil. It is usually measured by the depth of the water layer that can enter the soil in 1 hour. An infiltration rate of 15 mm per hour means that a water layer of 15 mm on the soil surface will take 1 hour to infiltrate. So, for clarification, infiltration rate is a measure kung gaano kabilis mag-enter ang water sa soil. So, mas madaling infiltrate ang water sa dry soil, and tinatawag itong initial infiltration rate. While as more water replaces the air in the pores, the water from the soil surface infiltrates more slowly and eventually reaches as steady rate, and ito yung tinatawag na basic infiltration rate. So next is infiltration capacity. So it is the maximum rate at which water can be absorbed by a given soil per unit area under given condition, and it is also called infiltration rate. So usually, tulad nung sa infiltration rate, usually greater at the start of a rain that follows a dry period, but it decreases rapidly. So a sandy soil as opposed to a clay-rich soil may maintain a high infiltration capacity for a considerable time. So next is field capacity. So the volume of water that the ground or soil can hold is known as field capacity. So the amount of soil moisture or water content held in the soil after excess water has drained away, and the rate of downward movement has decreased. So it is usually takes place 2 to 3 days after rain or irrigation in previous soils of uniform structure and texture. So example, a sandwich can hold much water. So factors affecting infiltration. So first is precipitation. Precipitations like rain and snowmelt infiltrate the ground surface to the waterbed. High intensity, duration, and amount of precipitation will lead to greater infiltration. So base flow, soil characteristic. So water infiltrates faster into large pore spaces, of course, subsoils. So this prevents runoff after the initial stage of water absorption. So next is soil saturation. So soil becomes saturated whenever it reaches its infiltration capacity. So once this maximum level is reached, the excess water will overflow as surface runoff. So land cover and slope of the land. So infiltration is faster in areas sa mga flat land surface compared to steeply sloped surface where the water will run off quickly. So steep slope surface encourage surface water runoff and in critical cases leads to erosion. So next is methods for measurement infiltration. So infiltrometers, observation from infiltration pits and ponds, placing a catch basin, artificial rain simulator, and hydrograph analysis. So first is the infiltrometer. So it is a device used to measure the rate of water infiltration into soil or other porous media. Commonly used infiltrometers are single ring and double ring infiltrometer, and also dispermeters. So there are two types of infiltrometer, single and double ring infiltrometer. So single infiltrometer, it involves driving a ring into the soil and supplying water in the ring either at constant head of or falling head condition. The operator records how much water goes into the soil for a given time period. The rate of which water goes into the soil is related to the soil's hydraulic conductivity. So next is the double ring infiltrometer. So it is a simple instrument which is used to determine the infiltration rate of water into the soil. The infiltration rate is determined as the amount of water per surface area and time unit which penetrates the soils. So these are the image of single infiltrometer and double ring infiltrometer. So the advantage of single ring infiltrometer are the installation and measurements are rapid with only one ring required, providing a measure of one-dimensional infiltration within the ring. So, ang disadvantage nito is device is the required pounding of the ring into the soil. So, a difficult task to adapt that can fracture a dry soil. So, mag-fracture ang dry soil. So, while the double ring infiltrometer requires the water levels within both rings be kept identical to prevent any cross gradients in soil below the rings which would affect the vertical infiltration. So the double ring infiltrometer has the same disadvantages as the single ring infiltrometer. So next is the observation from infiltration of pits and ponds. So these are rectangular trenches excavated at intervals in the channels of contour ridges for collecting runoff water, storing it, and allowing it until it infiltrates the soils. So the most basic and low cost of measuring infiltration. So these are the image of pits and ponds. So it is a water impoundment over permeable soils which receives stormwater runoff and contains it until it infiltrates the soils. So, next is placing catch basin. Lysimeter are foremost devices, typically tanks or containers that define a specific boundary to contain soil water and permit measurement of either the soil-water balance or the volume of water under. So these are the image of catch basin. So it is a large drain, as you can see, usually placed in low areas of a yard to catch surface runoff water. So next, artificial rain simulator. An equipment for determining infiltration, surface runoff, and soil and nutrient erosion characteristics of field sites. The equipment is robust and portable and can be rapidly assembled, operated, and dismantled by one person. So these are the image of it, and rain simulator is modified and its performance is evaluated through field measurements of infiltration, runoff, and soil erosion. The modified instrument is calibrated for various rainfall intensities. So next, hydrograph analysis. So a graph showing the rate flow or discharge versus time past a specific point in a river or other channel or conduit carrying flow. The rate flow is typically expressed in cubic meters or cubic feet per second. So, to clarify, ang hydrograph shows you the ways in which a river is affected by a storm. Kung sino yung affected ang storm. Maka-help din ito for us to understand discharge of a particular drainage basin and para ma-predict flooding and plan flood prevention measures. So, next, infiltration indices. The fee indices is defined as the rate of rainfall above which rainfall volume equals the runoff volume. So, it is relatively simple and losses due to infiltration, interception, and depression storage. So, phi index is equal basin recharge or over duration of rainfall, or phi is equal to P minus R over TE, or P is precipitation minus runoff over duration of rainfall excess. So next, W index. So it is the average infiltration rate during the time rainfall intensity exceeds the infiltration capacity rate. So W index is equal to FP over TR equals P minus Q minus S over TR. Where P is equals to total rainfall, Q is equals to surface runoff, S equals to effective surface retention, TR is equal to duration of storm during which I is greater than total infiltration, where FP is equal to total infiltration. Next is F average index. In this method, an average infiltration loss is assumed throughout the storm for the period I greater than F. Sample problem. The rates of rainfall for the successive 30 minutes period of a 3-hour storm are 2.6, 4, 6, 3.8, 1.2, 2 cm per hour. The corresponding surface runoff is estimated to be 4.5 cm. Establish the phi index. Also determine the W index. So for solution, summation of I minus phi times T is equal to P net, or the surface runoff. So, summation of it, 4 minus V plus 6 minus V plus 3 minus 8, 3.8 minus V plus 1.2 minus V times 30 over 60 is equal to 4.5. By shift solve, we can get phi index is equal to 1.5 cm per hour. Then for solving W index, we will first solve the P, or the precipitation. So 2.6 plus 4 plus 6 plus 3.8 plus 1.2 plus 2 times 30 over 60 is equal to 9.8 cm. So our RP is 9.8 cm. So for formula for W index, P minus Q over TR. So by substitution, 9.8 minus 4.5 over 3 will come up. The answer is 1.76 cm per hour. So that's all for my report. Thank you for listening, and keep safe, and God bless.